Okay, in this chapter, you need to focus on some concept. The first one is about digital and analog quantity. So second, binary digit, logical level, and digital waveform. Binary digit is if you want to know binary digit rules, so you can compare with numerical decimal number to understand how binary digit to work. Okay, so compare with decimal number to understand the binary digit. So in binary system, so we just have two binary digit, 0 and 1. So these two digits will correspond to two kinds of logical level. So in positive,
对不起，老师，我迟到了。
okay,
是阳光。
阳光 okay. Okay.
老师，我迟到了5分钟。
Yes, I already marked. You know, you can you that?
老师 late 5 minutes is not late. 老师 it was the network.
So because you're net for 5 minutes, so I will remark. I will mark. That means you net for 5 minutes. Okay. Okay, two binary digits will correspond to kinds of logical level. So in positive logical system, so high level will correspond to 1, binary 1, and low level will correspond to binary 0. So in negative logical system, so high level will correspond to 0, low level will correspond to 1. Usually we will use positive logic. So that is the relationship between logical level and binary digit. So in order to describe the information we will transfer, so we need to use a serial logic level to describe the information we will transfer. So that's a serial logic level will be called as digital waveform. So that will be high, and that means high level. That means low level. So waveform will be made up of a series high level and low level. Okay, so that is the digital waveform. So waveform is classified into two kinds of periodical waveform and no periodical waveform. So in periodical waveform is one that repeats itself at a fixed interval. So if you find some waveform which can repeat a fixed interval, so that means this waveform is a periodic waveform. So for periodic waveform, we need to grasp three characteristic pyramid. So the first one is period. So the second will be frequency. Third will be a duty cycle. So you need to remember that concept and how to compute that's characteristic parameter. Okay. So last class I already assigned some assignment to make practice for this question. Okay. So in order to use waveform to transfer a series of bit information, so we need to use clock signal to synchronize the wave series of bits. So in a general transfer system, so if you want to use waveform to transfer some information, you need to use another waveform, clock waveform, to synchronize the series of bits. So this cycle, each of cycle will transfer one bit. So system will sample some information according to clock signal. Each of clock, so system will sample one bit. So according to clock and some waveform, so you can get what information will be transferred using this waveform. For example, you can get this information according to this waveform and clock signal. One clock will transfer one bit. So that will be 101001101010. Okay, that's very easy to understand. Okay. So here you need to understand we can use timing diagram to describe the relationship between input and output of some circuit. So we can use mathematical formula to describe the relationship between input and output for some circuit. We can also use the waveform or timing diagram to describe the relationship between input and output. So in this diagram, we use several waveform, input waveform and output waveform to describe their relationship. So that is the description form for some circuit. Okay, in order to transfer some information, we can use two kinds of transfer method. One is a series transmission. So you need to know what is the characteristic for serial transmission. So for serial transmission, just one line is needed. All of information will be transferred using one line. So when you use this transfer way, so its expenditure is small, but the transmission speed is slow. So for parallel transmission, you can use many lines to transfer several bits at the same time. Therefore, its expenditure is large, but the transfer speed is high because we can transfer a lot of bits in parallel or at the same time. So that's why we say a transmission speed is high. Okay. So this fixed function logic devices is the last concept in chapter 1. So you just understand what is the IC. So what is the two kinds of IC. So in the following class, we will introduce some commonly used IC to help you to understand how to use IC to design your circuit, or what is the characteristic for some fixed IC. Okay, so here just have a memory for this concept. Okay, so IC means integrated circuit. So that means one IC is an electrical circuit. First, that is the circuit. This circuit will have that characteristic. So it's this circuit will be constructed entirely on a single small chip of silicon. So that's why we call that is the integrated circuit. So in this circuit, we will collect some couplant, for example, transistor and diode, or resistor and conceptors into the one chip. Sorry. So we call that circuit is the integrated IC. So usually IC will be divided into two kinds of. One is the fixed function logical devices. For this kind of IC, its logical function is fixed, and that fixed function is set by manufacturer, and user cannot be alert its function. So when you get this IC, you cannot change it. You can use it to design some circuit, but you cannot modify its function. Can you understand? That's why we call that is the fixed function logical devices. So in this class, we will use fixed function logical devices. We will learn a lot of fixed function logical IC. So you need to use this IC to design some circuit, some complex circuit. So in this class, we don't need to use programmable logical devices. This focus does not focus on this PLD. We just focus on fixed function logical device. Okay, so what is the difference between them? For programmable logical devices is the electronic couplant. This couplant used to build a reconfigurable digital circuit. Let's say it's reconfigurable. So unlike the logical level, which is a fixed function, a PLD, will have a fixed function. So when you take that PLD, you can change its function. So you can use some software to program it, and then you can get a different function using PLD. So that's why we call that is a programmable logical devices. Okay, so now we usually we will heard some FPGA. You heard that FP? Did you heard next concept, FPGA?
No.
So
No,
in embedded system, maybe we will use FPGA to fill the program get array. So that means you can so you can use this FPGA to write to set some function using circuit system private U. So that's this FPGA is kind of DLD.
It's more like
DLD.
Laoshi, useful for prototyping application.
Yes.
It's used in the embedded systems, right?
Yes, you're right. You're right. You can use C++
Yeah, C
or
C++.
or yes, VHDL to program to write your code and then download this your code in FPGA, and this PGA will realize or will implement the function that you program.
Yeah,
You
I know.
understand?
You have to use a fast compiled programming language like C,
Yeah.
C# or C++, so that it works well in the
Yes.
embedded system.
Yes, you're right. You're right. So that is a popular IC design. Okay. So after studying this class, you can to learn FPGA deeply. Okay. So but before you learning FPGA, first you need to understand this class. Okay.
This course, Laoshi, yeah.
Yes. This
Because
course,
it's hardware related, and in order to work with chips, you need to learn these concepts.
Yes, you're right.
It's mostly this class is mostly for back-end embedded systems. You know, works very well in those areas.
Yes. First, you can by studying this course, you will learn how to design some circuits, and then you can use some hardware language to design your circuit.
Yeah.
And then yes. Okay. Okay, so here give you the fixed function IC package. Commonly used, we will use that package. So when you see that style of chip, you will know that is some kind of fixed function IC. So that point is called as pins. Pins. Okay, that's a chip. So that's a chip. Chip is here. So this point is collected into this pin. So this pin will collect some circuit, and that means this circuit signal is collected into this chip. Can you understand? So this is called as pin. So here is give you two kinds of IC package. So that is the do-in-line package. You can insert this pin into some PCB for example, like this. So you can insert this pin into this PCB and using some wire to collect this pin into another circuit or another IC, so that you can collect different IC into one system to implement some complexity system. Okay. So about this this part, we will not discuss in this class. So you just read that picture I said you.
老师，我有问题。
Please wait, okay. So yes, today I already said that's material, so you can read that picture and to understand what is the complexity classification for IC. Okay, what is the two kinds of IC technologies. Okay. Okay, so please. What's your question?
老师, the fixed function IC package devices, what are they most commonly used in? Commonly used in what part? Like, for example, in which type of a system?
Commonly used fixed IC package?
Yeah.
So in all the system we will use this style IC package, but now in the modern system we use this style.
In
So
computer systems.
Yes.
Okay.
Just yes.
Okay. Can you
Like this? Okay.
Wait, Lasha, I want to take a picture.
Okay.
Okay, thank you.
And what is the function, Lasha?
It's used to implement what you put in.
It's a kind of a microchip, you know, and it has a lot of tiny resistors on top of it, and it can function as an amplifier or a microprocessor or a memory for the computer.
Yes.
Yeah, the IC. Sometimes, you know, when you have your phone and it burns, your screen doesn't work. It means the IC has stopped working, or even on your computer.
So.
Okay.
Can you see that picture?
Yeah.
Yes.
Yes, kind of a motherboard.
Yes. In this mainboard, we can collect a lot of components into the mainboard. So, for example, for here, this chip. Okay, I will find some. Not copy that.
It's the motherboard when you can put the CPU and the RAM.
Yes. CPU is the complexity. It is a special fixed circuit IC.
Okay.
Okay, so you can that is the mainboard for your computer. So we can insert some memory, and here is a CPU. So we can use different different kinds of package style to collect these devices into this mainboard.
Intel or
So
Ryzen.
this
AMD Ryzen
yes.
R9000 Lush.
Mm-hmm.
iCore.
Okay. Okay, so for chapter 1, we just know some concept. So to help you to understand the basic concept, so that you can understand the following knowledge point. Okay, so in the following class, you can understand this concept deeply. Okay.
Okay, Lush.
Okay.
Okay. So that is the chapter summary for chapter 1. Okay. So we already review about that in the beginning of this class. So now we don't need to discuss this part. Okay. We just skip that. Okay. So
This is interesting, Lush.
chapter
I
1.
hope the
Okay.
chapter 2 is the same.
Yes, yes. So if you're interested in hardware, so this course you need to study hard so that you can grasp the fundamental of circuit. Okay. That is the most basic for hardware.
Yeah, also for back-end embedded system softwares.
Mm-hmm. Yes.
Because sometimes someone may, different people buy chips and they want to program something in that chip, which is also very broad nowadays.
Yes, yes, you're
It's
right.
more electronic.
Yeah. I know there's a YouTube channel. He teaches a lot of stuff in this
I
subject.
know.
Okay.
You can
So
create
if you cannot understand what I said in our class, so after class I will search some similar knowledge points in internet, and I will send you to help you to understand what I said in our class. Okay.
Okay, Logic.
So you can use YouTube. So in YouTube, you can get a lot of video about
Yeah.
this course. Okay.
I know this one person who has a lot of videos on YouTube about this course. His name is Michael Reeves. I write his name in the chat.
Okay. After class, you can share that link to other students.
Yeah, I will.
Okay, thank you. Okay, that is chapter 1. Okay, so now we will start chapter 2. Chapter 2. So okay, chapter 2 is the basic knowledge, both basic knowledge point for this course. It is about numerical system operation and some code. So that's the first part is very, very important. So in the first part, you need to grasp how to implement the conversion between different numerical system. So that is the first knowledge point. And then when you transfer some information into binary number, so you need to know in computer system how to use binary to finish some operation. So you need to understand the basic operation for binary. And the third part, you will learn some commonly used codes. Codes means you can use this code to describe some information. We can use binary. We can convert decimal number into binary number, but for maybe sometime we need to represent some Chinese words or English letters. So you will use different codes to describe that information. Okay, that is the three kinds of knowledge point we need to focus on. Okay, that is the knowledge point structure for chapter 2. Number one is number system. The first one is number system, number representation, number operation. Okay, so now we will start from number system. So here give you the definition of number system. Number system is the scheme used to represent numbers by using a set of symbols and some rules. So please understand that sentence. Used to represent a number by using a set of symbols and some rules. So for number system, there are two kinds of characteristics. A set first, you need to have a set of symbols. First characteristic. And then second, you need to use some rules to count some number. Okay, to represent some number. For example, in decimal system, so that's set of symbol will be 0, 1, 2, 3 to 9. So that's will be symbols we will assign for decimal system. Okay, in decimal system, all of number will be represented using these symbols, these 10 symbols. These 10 symbols also is called as digit. You understand? Digit.
Yeah.
Can you did you remember that digit concept? Digit.
Yeah, every number system have a set of digits. Like binary system have a set of digits 0 and 1. 2 bits.
0 to
Yes,
1.
yes, you're right. Different number system will have different digit. So decimal system will have 10 digits 0 to 9. So octal system will have 8
Yeah.
8
8,
digits 0 to
7.
7. So binary system will have 0 to 1, 2 digits. For hexadecimal system, we will use 16 different symbol, 16 different symbol. We will use 0 to 9
A,
and A,
B, C,
B, C,
D.
D, E, F. Okay. Each of symbol will be in a single symbol, not complicated. Okay, can you understand? So that is
Yeah.
yes, that means number system will have a set of symbol. That symbol is called as digit. Okay. So in order to describe all of number, you need to use some rules. Some rules. Okay. For example, in digit system, we will use that's rules. Which is we will that's how to say, to in order to represent number, we need to generate carry when the sum is larger than 10. Can you understand?
When the sum is less than
A,
10,
B.
Sum is larger than 9. So you need to generate a carry for the high bit.
oh, when the
So
sum
that
is
is
larger
the-
than 9 or 10.
Yes, you're right. So if a number is less than 9, we can use single digit to represent that 0, 1 to 9. But if you want to represent 10, so you need to use two digit. You will use 1, 0. 10. So in decimal system, that's when what situation will carry 1 to the high bit when the lower bit is larger than 9. So you need to generate 1 bit to the high bit. Can you understand?
Yeah.
Okay, so enamel will be 1, 1. So 1, 9. So when you plus 1, so 9 plus 1 will be 10. That bit is larger than 9. So you need to check to generate a carry bit 1. And so this bit will be 0. So this will be the second bit will be 1 plus 1 will be 2. Can you understand?
Yeah.
Okay. So that's is called as rules, counting rules. Okay. So if some system has a set of symbols and some rules, you can call that system is number system. Any single, if this is any system that is contain a set of symbols and some rules, you can call that system as a number system. Okay. According to decimal system, you can summarize what is the set of symbol and some rules for binary, octal, and hexadecimal symbols and some rules. Can you summarize that two kinds of characteristic? Okay, so I will ask some questions, some students. Okay, so now the class. Okay, 4, 15. 15.
Yes,
Are you there?
yes, now I'm here.
Okay. So according to this example, so now please summarize what is the set of symbol and what is the rules for binary system. What is the series symbol for binary system? Four. Are you there? Okay, I cannot hear you clearly.
I'm here.
Okay, so did you understand my question?
Okay.
Okay, so my question is
No.
for binary system, what will be the set of symbol and what is what will be the rules? What is the symbol for binary or
What
digit?
is symbol?
So what?
I didn't
One.
understand the question last.
What is the symbols in binary system and the rules in binary system? Symbol.
The symbols. All right. Oh, okay.
Okay. Sorry, my pronunciation is not right. Okay. Yes, you are. Who are you?
You know how
22. Okay, so par. 22? Oh. Oh, okay, so please answer that question. Okay. 0 and what?
Lausi, do you want us to convert from decimal to binary?
Laushi,
Yes, I can hear you. So first, please tell me what is the set of symbol for binary system?
Laushi, I told you.
0, 1.
1 and 0. Okay, yes. What is the rules?
Laushi, I told you. No, number 14. To what situation will generate one carry bit?
معايا جاوب بس.
When the sum is larger than 2, so you need to just set one carry to high bit. So that is the rules for binary system. So according to these rules, how to represent a 3? Please tell me. How to represent decimal 3
1, 1.
Decimal
using
1, 1.
binary
1, 1.
1. Yes.
Conversion is
Great.
about conversion. Yes.
0 will represent 0.
0.
1 will represent
1.
1. 1 plus 1 will be this sum will larger than 2. So you need to set 1 into high bit to generate 0 with that will be 1. So that means 1 0 will represent
2.
2. 1 0 plus 1 will be 1 1. So 1 1 will represent 3. Okay. So okay, thank you. 22 Paul. Okay. Okay, next. Book. Yes. Are you there? Hook.
Live on number
16.
16.
16. Okay. So how to represent 3 in decimal in octal system? Octal system. Represent 3. I cannot hear you clearly. So can you send the message here? So how to represent 3 using octal system?
It's 0 1 1 Laushi.
Teacher, can I try?
0 1
Um,
1. Octal system, not binary. Octal system.
Now in octal system, 3 is 3.
3.
Yes,
3 is
3.
3.
Three
Yes.
is 3
Right.
Laushi.
3 is also is 3.
Yes, Laushi.
Because we in binary system we have binary 0
1 1.
1 2 3 4 5 6 7. So we have 8 symbol to represent any number. So in order to represent 0, we will use 0. In order to represent 1, we will use 1. In order to represent 2, we will use 2. Okay. 3, 4, 5, 6. Okay. 7. Okay. Now, how to represent 8? How to represent 8 in octal
8.
system?
It's 1 0 Laushi.
10,
Yes.
1, 0.
1 0. Not 8. Not 8 because we have no 8 symbol. So
0.
7 plus 1 will equal to 8. So you need to generate carry 1 to the high bit. So 7 plus 1 will be 1 0 in octal system. Can you understand?
Yes, Laushi.
Yes.
Sure.
Okay. So 9 will be 7 plus 2
1
will be 1 1. Yes, you're right. 1 1. So 1 1 will represent 3 in binary system, but 1 1 will represent 9 in octal system. Can you understand?
Yes.
Okay. The same form will represent a different number in different number system. Can you understand?
Yes, Laushi.
Okay. The first section is in. So we have the 5 minutes rest and then please come back. Okay. So we will continue to discuss.
Okay, Laushi.
Okay. Thank you. So in order to understand the number system, you need to understand this 3 elements. So first, symbol sets, and the second is base. Base is the number of digits used in this number system. For example, in decimal system, so that base will be 10. So the binary system, so that base will be 2. Octal system, the base will be 8. Hexadecimal, the base will be 16. So base is the number of digits in this number system. So I think that is easy to understand. Okay. So in order to know a combination digit, what number will be represented using some combination combined digits. So you need to know position weight. So for different position bit, so that's digit will have different weight. So according to digit and its position weight, you will get that's for what number will be represented using some form. Okay. So for example, in decimal system. So for each of position, we will have different weight. That's weight will be, for example, that's 1, 2, 3, 3, 1, 1. Okay, so we have for this number. So this number have 1, 2, 3, 4, 5, 6 digits. So for each of position, its weight will be 10 power of I. So that will be 10 power of 0. The next, its weight will be 10 power of 1. Okay. The third will be 10 power of 2. Okay. 3. That will be 4. 10 power of 4. Okay. So that's number is called as a position weight for each of digit. So that's 1. If this digit is 1, that means this number will be 1 because 10 power of 0 will be 1. Okay. So the second for the second position, so that's a digit is 1. Its weight is 10. So that number will be 10. For the third position, this digit is 3, but its weight is 100. So that 3 will represent 300. Digit multiply its weight, you will get its corresponding number. Okay, that is digit 3, but its weight will be 10 power 3. So that's 3. Digit 3 will represent 3,000. Okay, that will be 20,000. Okay, 200,000. Okay, so its real number will be get by summing this number. So 20,000 plus 200,000 plus 20,000 plus 3,000 plus 300 plus 10 plus 1. So it's this form, this decimal form will represent that number. It's the real number. We will use this number, this form to represent that number. Okay, so that means its real number is related to its digit and its weight. Okay, that is the position weight. So that is the that is the decimal position weight. For binary system, that weight will be 2 power of I. For example, 1111. So its real position number will be for this digit, its weight will be 2 power of 0. This will be 2 power of 1, 2.
So by adding them, we get the required solution?
Yes, you're
Okay,
right.
so for the last one, the answer is 223,310.
That is not 200.
No, I mean 223,310. The summation.
Yes.
Okay.
Okay. So that's 1111. That is for binary system. That's 1111 will represent some number, but its real number will related to its weight. So for this position, its weight will be 2 power of 0. That will be 2 power of 1. Okay, according to this rule, so that's 1 will corresponding to 1 multiplied by 1 will be 1. This 1 will be 1 multiplied by 2 will be 2. That means this 1 means 2. This 1 will means what? 1 multiplied by 2 power of 2 to 4.
Power 2. 4.
Yes, that's 1
And
means
1.
2. That's 1 means 8. So plus them.
It's 15.
So will be 15. So that means 1111 in binary system will represent 15 in decimal system. Can you understand?
Yeah.
Yes.
Okay. So that is the weight for binary system. According to hexadecimal and binary system, you can summarize the digit and its weight for different number system. Okay, so that is this table gives you what is the digit and its weight for different number system. For example, for decimal system, its base is 10. Digit will be 0 to 9. Its weight will be 10 power of I. I will be the position for some digit. So for binary, its weight will be 2 power of I. For octal system, its weight will be 8 power I. So hexadecimal, its weight will be 16 power I. Okay, can you understand?
Yeah.
Okay.
Depends on the amount of digits.
Okay, yes. So here you will understand a different representation form for some for the same number are different codes or different marks of this number. For example, the same form will be 1111. In decimal system, this number will be decimal system. This form will represent a decimal number 1,100 and 11, 10 plus 1. Okay. So 1111 means 1,111 in decimal system. But 1111 will represent what decimal number will be represented for 1111 in decimal system. So 1111, if 1111 is the form in in binary system, so that form will represent 8 plus 4 plus 2 plus 1. So that will be 15. So that means 1111 in binary system will represent 15 of decimal system. Okay. So for octal system, so that's 1111 will be 10 power of 8 power of 0 will be 1. 8 power of 1 will be 8. 8 power of 2 will be 64. Okay, another 8 power of 3 will be 1. Okay, so 512. So that will be this. Okay, so that means 1111 in octal system will represent that will be 512 plus
It's 85.
that's right.
No, 85.
Oh, sorry. 73. Okay, so 583. 583. So that means five. Sorry, 5. Okay. So that means 1111 in octal system. So will represent the decimal number 585. Okay. So for hexadecimal, 1111 will represent 16 power of 0, power of 1, power of 2, power of 3, plus them together. You will get its corresponding real decimal number. Okay. So that means for same form, if you use different system, you will get a different decimal number. Okay. Okay, that is the 111 different weight to show you what is. This is 8, not 7. Okay, that is binary. Will represent 15. Okay, so when you understand what is the number system, so in order to convert other number system into binary system, so you need to use different way to convert decimal number or octal number or hexadecimal number into binary, or convert binary, octal, and hexadecimal number into decimal number. So you need to understand how to finish the conversion between different number system. Okay, first. So here we will focus on the conversion from base R system to decimal system. Base R means R can be 2, 3, 4, 8, any number. 8 or 16. So usually we will use two octal and hexadecimal, base 3 or base 4 or other base any other base R system. We don't use that. We usually we use 8 or 16 base R system to represent some number. So now we just using some example to show you how to finish the conversion from base 2, 8, 16 to decimal system. Okay. So here show you the conversion method. In order to implement the conversion from base R to decimal system, so you can use this method to multiply the decimal value of each digit by its weight. Multiply digit by its weight and take the sum of these products, you will get its corresponding decimal system. So that method is very easy. For example, so please convert the binary number 110110 to decimal number. So according to this method, multiple digit by its weight and then take the sum, you will get its corresponding decimal number. Okay. So that is the solution method 111101. So from low position to high position, from right to left. So that's weight will be 2 power of 0, 2 power of 10, okay, until to 2 power of 6, okay. So that's bit. That digit is 1. So 1 multiplied its weight. Okay. The second bit is the second digit is 0. So 0 multiplied its weight. Its weight is 2 power of 1. Okay. The third digit is 1. 1 0 1 1 1 0 1 1 0 1 1. Okay. Multiply its corresponding weight. And then take the sum. Take the sum. You will get its corresponding decimal number will be 109. Okay, can you understand? Okay, so that is the conversion from binary to decimal. Okay, so here I give you the example. This example is about integer. So for a fraction, it's the same, but its weight is different from integer. So for example,